Mass TLC's robotics cluster visited Spaulding Rehabilitation Hospital for a demo of Hocoma's adult and pediatric Lokomat rehabilitative robots. Hocoma's CEO, Charles Remsburg, explains.
So the robot is it's not an intelligent robot per se. It does have force control, force feedback. Ian's work is his research is specifically to create different control loops that are more driven by the patient and less by the robot. But the point is, the real value of the thing is that two therapists don't have to get down and do this, and which they can only do it for a short period of time. Now they can do it for a much longer period of time. That was the basic premise, and I think some of the research you might want to share, Ben, on the kids, is it's taking kids, and we talk about adults relearning to walk. You take a child who's never had a physiological gait pattern and induce a physiological gait pattern on a repetitive basis, lo and behold, the child's brain is probably the most, what's called neuroplastic. You end up teaching the child to relearn in a far more efficient, more effective way, thereby improving the outcome for the child, reducing the cost of the healthcare system, and doing it in a way that's very cost effective for the hospital. You have the opportunity to do is open up the gait pattern based on the amount of guidance force that the robot applies to the individual. So take, for example, a hemiparetic patient, a stroke patient. They lose motor function on one side or the other side. So with a robot, you wouldn't want symmetrical assistance, you want an asymmetrical assistance. So you're able to open up the physiological gait pattern on the involved side so that the robot provides less guidance force and forces the individual to work within that gait pattern to try and produce a more functional and more physiological pattern based on their injury. It's guiding them. It's not forcing them through a particular pattern.
But what you do is, first initially when you set up a patient, you get all the mechanical setup correct. Because if the mechanical setup isn't right, then any software changes you make aren't going to be any use to you. So basically you need to get the axes of the hip and the knee joints aligned to the patient, get the axes of the actual mechanism aligned and the foot position sorted out. And then you can make fine adjustments in terms of the software changes. So if the patient doesn't have sufficient hip flexion, you can actually change the offset, so you're putting him into more hip flexion, or you could change it to increase hip extension. Likewise at the knee, you can actually promote increased knee flexion or extension. Typically the way gait training is done is that two therapists will be sitting either side of the patient. They'll be receiving body weight support from a system up here, which the patient is receiving the Lokomat. But then you'll have two therapists manually moving their legs, the patient's legs, through that movement pattern. And then you may also have a third therapist at the back providing pelvic control or pelvic stability. So with this system, there's the potential to have one therapist training a patient and then with the assistance of an aide. So at the moment, the augmented feedback is more to provide them with a bit of motivation to walk. We can use it to teach them turning, because if they exercise harder on one side, for example, if they create more hip flexion or knee extension, then they can turn to the left or the right. And that's what we're primarily using with the children at this stage. But at the moment, it's more to engage them so they actually walk for longer.